Do we have a clear ending for that? Are we cool with that?
Let's bail. Let's get to the podcast. Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm managing editor Tom Nardi.
This is episode 192. We think Supercon was awesome, and we'll be talking about how to grind ICs and make your own telescopes. And the two of us were at Supercon just a few days ago.
It was awesome. It was an awesome experience. Anyone who got to go, I'm sure, is still riding high from it themselves. I think it kind of reinforced something that we all realized, is that, the virtual events were fine, but there really is no substitute for just hanging out with people in real life and just all the wild kind of things that happen and seeing all this creativity live. Just walking up and down in the alleyway and seeing everything that the people were working on I would have paid admission just for that, even if there were no talks and no tacos, I would have paid just to walk up and down the alleyway and see all the incredible stuff that people were working on.
I have to say the badge hacking this year came off superb. I've never seen so many really, really cool hacks. I was thinking about this, and some of it I think is probably down to the badge. Avoya's badge was, this kind of weird mix of really educational and really deep, but also at the same time just super accessible because everything is press a button, get an LED, enough LEDs together, it makes a functioning computer. And so that was really fun. We also started up Friday morning a lot earlier than we did before. Yeah. We started up at 9 o'clock. I think before we'd done evening early badge registration, and then that kind of crept into mid-afternoon, and then that kind of crept to noon. And this time we're like, we'll just throw it open at 9. Actually, people were outside the door at 8:30 and we let them in too. So it was a whole extra day of kind of mellow mode Supercon on Friday. And I think a lot of people got a good head start on working on the badge and learning how it goes. And, a little bit more time for badge hacking leads to lots more badge hacks.
For people of a certain age, there was a certain nostalgia to it.
Right.
And then, for the younger people, like you said, it was educational. So you really walked that fine line, which I don't know what we're going to do next year. I don't know how you recreate that. It really was kind of like lightning in a bottle, because it was just complicated enough to keep the experienced people engaged, but also accessible enough that even if you had never done assembly or even bare metal push button front panel programming, you could still get away with creating something fun in your first sitting.
I think we say that every year, though. Every year we're like, this badge is the coolest badge. What are we going to do next year? And then we try to figure something out. So we'll figure something out. If you're at all interested in following along with the badge stuff, what went on, we do have a GitHub up and there's an emulator, and at least some of the programs run on the emulator. We're still kind of working all the bugs out of the emulator. Writing an emulator for a virtual machine is strangely hard. How's that possible? It should be software all the way down.
Yeah, right.
Simple matter of software. The other thing that happened at Supercon was we revealed the Hackaday Prize winners. There were 5 rounds of finalists, 10 finalists per round. Our panel of judges then picked the best of the best, and we announced it on Saturday night. That was really fun. First prize went to a 3D printed portable wind turbine. And this seems kind of on the surface maybe a little underwhelming, but this thing is just so well done. It's meant to be backpackable, so it has to it fits in a 2-liter bottle when it's all folded up basically, and it still produces, with some decent wind, a couple watts of power. And I think that's what's most amazing about this, is it wiggles into this niche where it's both small enough to be, you can bring it with you, but it's then also powerful enough that it does something useful, and a sweet design to boot. And yeah, I see why it won, actually.
Remember the judges saying that too. It really was the documentation, and the professionalism on this one really put it over the top. And that is something, keep that in mind for your entry for next year. That's something that the judges are definitely looking for. You can have an awesome design, but if it's just a couple pictures and some incomplete documentation, that's really going to hurt you in the running. I mean, it's all the Hackaday Prize is all about, sharing this information, right? And to be a contender, you really need to be well documented. It needs to be concise and everything out there. So ideally, somebody could recreate it on their own.
Yeah, and this one's totally ready to go. Like, you can just print these parts up and you are set. I was really appreciative that they did a lot of actual real world testing, and 4 or 5 different prototypes went through, and optimizing the blades and stuff like that. And actually, one of the really cool things about a 3D printed turbine is that he has a couple different blade angle of attacks that are already built in. But if you think you're going to be in a super low wind environment or a super high wind environment, you can actually print different blades for it and play around with optimizing it yourself, like Adrian did. Oh my God, did you see the video, his acceptance video? That was super emotional. That was really, really brutal. He totally choked up when he discovered that he won.
I warned people that too. I was like, when they get to the awards, don't be surprised if you see some dabbed eyes in the audience, because it is,
yeah, right?
It'd be life-changing for some of these people. They're talking about a large amount of money, and then you get the residency at the design lab. I mean, this is huge. It's not like, here's your Dunkin' Donuts gift card for making a wind turbine. This is real stuff.
Yeah, for sure. I hope it helps him start something cool with it. But on the other hand, it's an open source product, so you don't even have to wait. Print it yourself if you want it. You know what I just realized? We didn't do What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
Well, let's try a What's That Sound this week. What do you think about that?
Yes, totally natural response. Well, I would say, right?
That actually is the answer, I think. I don't think anything more than that is.
There's nothing more. Okay, it wasn't like there's a specific.
No. I think that's a totally acceptable answer. Awesome backstory for this one. We can't tell you what it is, but this was actually suggested to me at Supercon by Mike Stitch. He was like, "Hey, you know what you should do? You should play the sound of a..." And so here we are. If you can guess what the sound is, and it's not too specific, head on over to hackaday.com/podcast, fill out the form you'll find there, and let us know your best guess. Next week, I'll give it a read on the air. I'm throwing in an easy one this week, partly to make up for not having a What's That Sound last week. Sorry, y'all. My first hack this week, how those NES dip chips were reduced to QFNs, is a follow-up on a previous post that we wrote. And basically, Red Herring 32 took these like really large 40-pin dips that are inside an NES and cut them down so that they're basically like quad flat pack, no lead type chip form factors, by carefully sanding the bottom off, exposing the lead frame, and then kind of cutting around that, leaving basically a QFN in its wake. I think I was talking about it with Dan Maloney on the podcast, and we were like, oh, I really got to see how he does this. Well, finally, that's what is here. And so we had to write that up. There's a full tutorial, if you click through, on how he did the chip trimming, and that's the part that I was looking for. It's really nice. It's a little bit of a video guide, and the answer is that thing that we thought was a shim to make it easier to sand the die flat was exactly that. It's a 3D printed die holder, and he was holding it up to a rotary sander. And he mentions that he gets all the way down to where you can just see the die pad and then do the rest by hand really gently with a Dremel tool. And so that's an interesting procedure. And again, it just looks so pretty when it comes out. You get to see the pin frame and the die in the middle. He then Dremels the thing out, and the only part here that I didn't anticipate is that, of course, you're looking at the IC from the bottom side, not the top side, which means you don't get to see any of the bond wires that go out to what will become the pins. And I hadn't thought about it, but he mentions it, that you have to cut with a little bit of extra space around there So cut a little bit bigger than you think you do. He says exactly 10 millimeters by 10 millimeters. Not much bigger and certainly no smaller. Otherwise, you'll cut up traces you needed.
It's really remarkable when you look at it, like how little of the chip was actually useful. The die is so small. It's well, I certainly didn't expect so much of it just to be package. It's like 90% package. Like it's crazy. You almost wonder, why did they make it so small? Like it must have been more expensive to make just a small process to do the die, right? Like they could have been a lot bigger. It reminded me a lot actually of like the Wii motherboards. Like it cut down to make the portables.
Yeah,
this is kind of this is sort of on like the macro scale, right? Because it's instead of the whole thing, it's one chip. But it's the same principle applies. You cut off all the stuff that's not really required, and you wire it up differently, and all of a sudden it is a real console. It's not like emulated, but you can put it in a much smaller package. So it's kind of cool to see that same technique applied to the original Nintendo.
This GitHub includes all the hardware you need to make a Nintendo fit in a Game Boy form factor. If you want to, it's got all the little subboards, including the one that takes these now QFN parts to fit them in there. It's really kind of fun. He also includes, of course, the footprints for them. So if you ever need to, I don't know, cut down your own other chips and include them in a project, you totally can. It's just crazy.
Well, my first project comes from Science Shack. This is a radioactive dice roller, I guess is the simple way to put it. And it's something that believe it or not, we've seen before. This isn't the first time someone has said, you know what I want to do? I want to use radioactive material to pick my game move. But it makes a lot of sense, right? Because you can get true random numbers by calculating how often you get like the K off the sample or whatever it is. Something that's truly random. It's not the pseudo random that we usually get from electronic devices. The thing I really liked about this one, well, it's kind of two things actually. I liked how reasonable it was in terms of like size and interface. Some of the ones we've seen before, and we could put the links in the notes. They really, really played up that whole nuclear energy fallout vibe. And they were cool, don't get me wrong, but they were giant. And it wasn't the kind of thing you're like, hey, I'm going to bring this to your house to play a board game. Like this one, I think this one's specifically for Dungeons and Dragons. This looks like something you could pretty legitimately put in the middle of your dining room table and get some random numbers, which is really cool. The detail I really like, though, is that they said that the material they were using, was far more radioactive than was necessary. Don't you hate it when that happens? You're like, oh, man, this is way more radioactive than I needed for my project.
It's a winner. It's a winner.
Yeah. So they took a smaller amount of it, and they put it inside this plastic tube to make what they call, I think they call it like a fuel rod or something.
Yeah. I
don't know if I missed it in the video or they didn't say it. It looks like it's this, they took the little bits and they suspended it in like epoxy or something, so that they have this little cylinder of the suspended green radioactive material that, of course, they hit with like a little UV LED, and it just looks so cool. And it looks like it has like a proper little like nuclear fuel rod, like some Simpsons thing in the back. And there's a little window too on the back, so it's like you don't go through a lot of trouble and hide it, right? Like you make sure there's a little window so everybody you're playing with knows you're playing with nuclear power. So I just think it's a really cool build. And of course you could use the same principles to do random number generation for your computer and do encryption and stuff, but that's not nearly as fun.
Yeah, I mean, it's just one of those things. Do you need absolutely random numbers for playing D&D? I'm not so sure, but no, it's totally awesome. You can dial up, how many sided die you want, and then you can dial on the other side how many of them you want. Then you press the button and it goes. It does take a while to generate the random numbers because it's collecting clicks, I think, and that's kind of funny. I don't know the autonite, which they're calling it. Like, what is it? Is it an alpha decay? In which case, this is probably no problem because it's inside a little box, or is this putting out something worse? I'm hoping it's totally okay.
Dan does mention in his write-up that maybe some gloves would have been in order when handling the nuclear material.
Yeah, right?
So I guess there's at least some concern. You only live once, right? You gotta get them YouTube views.
I wonder if you could also shield it so that it's not really a problem.
Well, a phenomenal shield is water. So you could do like an outer vessel of water with the thing inside of it, and as long as your sensor is close to it, you could do something like that. It's like a double walled kind of thing. Yeah. And then obviously it's you can see through it. Like you said, if it's an alpha, I mean, I think a couple inches of air is really all you need.
Yeah, well, and certainly whatever acrylic
Right. So
window
if
they've got there or whatever, you're probably all right.
A decent piece of acrylic, you're good. But still, maybe keep all the important parts of you away from the dice roller. For a long time, I wanted to get like uranium glass and then melt it and then pour it into like kind of like what they did, like a rod, and then have like a rod of uranium glass that you could like put into a thing like this.
All right, my next hack, smelting solar style, is something we've seen before, but I've never seen it work this well. This is Jelle Seeger's project. It's basically a Fresnel lens that he uses to get a little crucible hot enough to melt a fair amount of metal. And by fair amount, we're talking 20 kilograms of zinc or 5 kilograms of aluminum. And that's, on a sunny day. And he does have to crank the thing so that it follows the sun, right? Think about the magnifying glass, focusing the solar energy down on the crucible. But that is just crazy. And this is one of those things where, everybody says there's a lot of power in, a bright sunny day, and when you write it on the back of paper, you figure out that you can get a lot of power out of this, but nobody ever does it. And here is somebody who did. And what's really cool is that it looks like he made the Fresnel lens himself. He got a bunch of big acrylic plates and combined them all to make an even bigger one, put it in a metal frame, and he built a kind of, it looks a little bit like a compass, except out on the end is a cutter. And so he's actually cutting his own Fresnel lens into it. There's a hole in the middle of it that he used for a bolt so that it stays on a fixed pivot, and then he traces around, cutting one of the kind of, I don't know what they are with a Fresnel, they're those lens faces, and then he adjusts the angle and he does it with the next one, and then he adjusts the angle and he does it with the next one. That is just fascinating to me, that he's able to make by hand in, sheet acrylic, a giant Fresnel lens that, if you look at the picture here and some of the pictures in his blog write-up, it's not like an optically perfect lens, but that's not the game here. The game here is just to get as much of the sun onto this one spot and melt some metal. And that, it seems like he's able to do. And I think that's just rad.
This is how I'm going to melt the uranium glass.
Oh, glass would be easy with this thing.
Right? Not that using the sun to melt aluminum isn't cool, but I definitely think the custom lens is kind of the hidden gem on this one, because I guess it's a matter of necessity, because if you needed something smaller, you could probably get it off the shelf. So
right.
no one's ever decided, like, I guess I'll just etch this by hand, but it never occurred to me that you could do it. So it's pretty cool. And I'd like to see what it like doing it on a smaller scale. If you needed to do these like custom lenses and stuff, that'd be kind of interesting. Or even like doing a CNC or something.
Yeah, CNC is exactly what I was thinking. I was like, oh man, you could totally do something like that.
Yeah, I mean his method works because it's giant, But if it didn't need to be so giant, you could do it, on a CNC, and that'd be really cool. To what end, I don't know. That's not our department. Like we don't we don't have to figure out what it's for, right? We just have to marvel at the people making them. So now that I've seen it's possible to make these lenses, I can't wait to find who's making little bespoke ones for their own projects.
Oh, look at this. You go looking through the comments, and of course we're not the only people who thought that the mechanism for making the lens was awesome, but Jelle Seegers comes in himself and says hi. Somebody was suggesting making a spiral Fresnel lens, and I don't know if that's even possible. That would be too confusing, I think. But he says he didn't think about it. The outer angle is at 40 degrees, and he just works it from there. That's really interesting. It says he sent some extra pictures to the editor. Ooh, cool.
That's us.
I'm going to go look that up. Hopefully it'll be posted up by the time you're listening to this podcast. That's really awesome.
I know the editor at Hackaday.
At the moment, I'm working on an improved method for making more precise and even way bigger lenses, like 5 meters in diameter instead of 5 meters square. Holy cow. And now that I found out people are interested in this, I'll document this better and share. Thank you, dude. That's fantastic. Okay, I'm looking forward to that. Hopefully, I'll be able to scrounge up his photos and post them for you. This is just in this afternoon, so this breaking news.
Break. Speaking of comments, I like the one person who's like, if it works this well in Holland, I can't wait to see how it works where I'm at in Western Australia.
Yeah, dude, where people have sun. Yeah, no joke. Yeah, it's funny. If you look at the angle he has the thing tilted at, you could tell he's somewhere in Northern Europe because he has it keeled way over to catch the low sun. So, yeah, totally.
Is the hand crank, is that just part of the aesthetic?
I mean, you could motorize it.
Certainly, but like,
it's easy enough to make a motorized sun tracker, right?
Is it like intentional? He did it by hand so he could say it's a fully, you know what I mean? Like it's part of the statement probably. Like you don't need any electronics to do this, and it says like every 5 to 10 minutes he has to crank it or something.
That's right. He's doing it with no power at all, so that's actually pretty rad. I mean, he's doing it in the middle of this courtyard. He'd have to run an extension cable out if he had a motor. It may actually just be easier to hand crank it.
Actually, in the full article, it says, by making it manual, it really changes the casting craft from one where you have endless energy coming to your workshop to one where you personally cooperate with the sun. So he's cooperating with the sun.
Fair enough. I got it.
Little art house for me, but I give him credit.
Yeah, 5 square meters is 5 kilowatts of solar energy. That's crazy.
End of the world comes. I want this guy in my corner.
Yeah, you do.
So this next project is something that I've actually had my eye on for a while. I don't have any excuse for why I didn't write it up personally. It is a 3D printed telescope. And of course, we're not talking about the optics and stuff here. We're talking about the actual frame parts that uses largely like off-the-shelf hardware store components. You still got to buy the lenses. You're not grinding things by hand. But even still, all told, with filament and the little bits and the lenses, it's under 150 US. And if you know anything about telescopes, you'll know that if you tried to go buy a telescope for $100 or even $200, what you're going to get is not great. The creator of this telescope, Hadley is what it's named, says that those are what we call hobby killers. Because you go out and you spend $200 on a telescope and you take it in the backyard and you see nothing. And you say, well, this is stupid. I can't believe I spent $200. I'm going to go watch YouTube. That is like the full trajectory of many a amateur skywatcher's career, right? Yeah. So the goal was to build something that would still fit in that price range, but actually give you some decent looks at the moon and the planets and stuff. You could even use this for astrophotography, although it's a manually aimed thing, so good luck trying to catch Jupiter or something by hand. But still, it's a great platform to start with. And it's really been growing. When I first looked at it, only a couple of people had built them, and it was all U.S. sizes. And then, of course, you had people say, well, okay, that's cute, but I can't get, U.S. sized conduit and stuff in Europe. So then they did a metric kind of remix. And now there's a company that's actually selling the mirror kits. Before there was like some AliExpress links and stuff for the mirrors, but you still kind of on your own. So now there's one kit you can grab with all like the non-printed parts. So it's really becoming a lot more accessible to more people. I think it's cool on the project page. He's got this gallery of all the little people's printed ones. It's just really cool to see, all the different colors and all the different customizations you can do. And I think if you've ever been, disappointed with the options that are out there for a reasonable price, like if you're willing to spend, $1,000 or something, then probably just go do that. But if you're trying to get into it for not a crazy amount of money, I think you'd probably be better off just building this than buying whatever the recommended scope on Amazon is for this price point.
Yeah, and I think the real winner here is that he's kind of buying the best compromise optics he can get for the money, right? Like, so it's I guess it's 90 millimeters. So it's kind of a 4-inch scope, which is a good size. You can do a lot of, especially inside the solar system looking with a scope that size. And that's at a price point where the optics don't cost more than like $50. So you can do something that's pretty good and still get away with it without breaking the bank. And I think, again, he's hitting a real sweet spot here. It always surprised me with these like do-it-yourself scopes, how often they don't have any frame on them at all. And if you haven't seen the pictures of this, it's really just 3 tubes and then a bunch of 3D printed bits that do the alignment. And that's the whole game. Like, when I think telescope, I think of something that's got a big solid tube enclosing it. And this is just out there floating in the air. But of course, if you think about it, that's the light goes through the air anyway. It doesn't need to be in a dark tube. Light doesn't know any better. So it's kind of cool to have it be one of these ultra minimal scope designs. And it uses kind of the classic build a box and put a pivot in it kind of alignment tripod kind of thing. And all of this stuff has been tried and tested in the amateur astronomy community for the last 40, 50 years. And this is just kind of in a way, like the 3D printed evolution of some pretty old ideas. And I love to see it. It looks really rad. It looks like I need to make one.
My friend had a real big, I want to say like 10-inch Celestron or something. Yeah. Like a proper like this kind of thing that, it was a big deal to even take it out to the field. And even that, like, you do need to know what you're doing.
Yeah.
I mean, part of it is, it's like anything else, like there's still skill involved, right? You still need to do the best practices. I mean, I remember we were using like an app on the phone, like a Skywatcher app. So we're staring at the phone screen and then looking in the eyepiece and be like, oh, I don't see nothing. Well, maybe if we weren't just staring at our
blind.
Yeah, we weren't staring at our phones in the pitch black outside, but we were idiots. So you still need to be aware of those basics. But I would venture to guess that if you went through the trouble of building this thing, you probably are dedicated enough to use a red flashlight or something.
He's saying there have been more than 100 builds. So that's
awesome.
A fairly widely replicated project. And he has a bunch of his pictures, but then he has a bunch of the contributed pictures on his website here. And some of those look really awesome. My next hack is a video from Look Mum No Computer. It's Rope Core Drum Machine. Now, this thing is fantastic. It uses the same idea that used to be used for storing kind of fixed amounts of binary data back in the way, way old days, before diodes were cheap and easy, before, ROM was available. You could store memory by running wires through a bunch of coils or not. And the way this works is that if the wire runs through the ferrite, it transmits the signal, and if it doesn't run through this ferrite, it doesn't transmit the signal. 1 and 0. Here, this is just a fantastic tutorial in this kind of ancient/extinct way of encoding binary patterns in coils. On one side, he's got a 555 timer, of course, putting out a square wave, and on the other side, he's got a comparator seeing how much voltage is coming through this transformer. In between is a ferrite ring with a bunch of coils wrapped around it on the receiver side, and on the transmitter side, the wire either goes through it or it doesn't. That's as simple as it gets. Now, he turns this into a crazy drum machine. That's where it gets really interesting. There's a tangle of wires here like you have never seen before, because he's got a bunch of different instruments that he wants the drum machine to trigger. So he's got like 8 of those. And so that's 8 wires that have to snake through. And then he's got a bunch of different patterns. And so that's 8 times however many patterns he's got. And he has a big rotary switch that switches one set of 8 in or another. It's really fantastic, mostly because it's crazy. This doesn't make any sense in this day and age. You could do it with a diode array. You could do it in a million other ways, but this is just so incredibly hands-on. You get to like weave your beats. As usual with Look Mom No Computer videos, half of the fun is his enthusiasm for the project, and the other half is his fun accent. And my absolute favorite is when he says threshold, he actually says freshhold, and that's pretty sweet. I think I'm going to say freshhold from now on. Oh yeah, that's a 3-volt threshold.
Comparator threshold would be a t-shirt.
Comparator, that's what he says. Comparator.
Threshold.
Comparator? Comparator.
I like how, like Jonathan points out in the write-up here, is like the size of the ferrites.
Oh yeah.
It makes it practical. It's not the right word, but more practical than the poor women who were stitching the Apollo programming into the thing, right? And I guess the idea was that you want to be able to change this one, right? This isn't getting stitched one time and getting launched to the moon. So
Right.
you want that flexibility to be able to change it with relative ease. And specifically because I think it says he wants to take like submissions from the community, right? So he wants to be able to like pull the thing out and rewire it without having to use a microscope or something. But it's an awesome demonstration of the concept, right? Even if it wasn't hooked up to a sequencer for making music, I mean, it's really cool. It's almost surprising. This is like the first time we've seen like this large scale rote memory, because it does kind of make it a little easier to understand than what we've seen previously.
Yeah, he said he got the inspiration from an old Soviet auto dialer machine that does exactly this. It's got even more toroids in it. I don't know how many digits it needs to dial, but it has a whole ton more toroids in it, and was programmable by the end user by just running these wires through back in the day. And that's
which we've written about too.
That's really cool. I mean, I like that by itself as well, but then this turning it into something, even more mental is pretty cool.
Yeah, so that it's actually linked in there. We wrote about that before. Mike's electric stuff tore one of them apart.
Oh yeah,
and it looks remarkably similar. We
need to get Sam from Look Mom No Computer out to Supercon. Mike was there. I had lots of talks with Mike Harrison. Mike is awesome, and I'm going to have to lean on him to get Sam to come out for the next Supercon. The thing that surprises me most about this, looking at it, is that there's no crosstalk from wire to wire, because you have to imagine, I guess he's using a fairly low frequency. He said it was like 1.5 kilohertz square wave it's putting out, but still, if you have 8 instruments, then 8 of these red wires are carrying signal, and all the others are just kind of floating in the breeze. And you might expect them to pick up the signal and carry it through their toroids, but they don't end up doing it.
Still quite a bit of red wire.
Looks like he pulled it off, so kudos.
The rats trained him well on this wiring. Well, I saved the sad bit of news for the last, because by the time you listen to this, your Slingbox is dead. Now, you probably didn't have a Slingbox because they were popular in I don't know, 2010s maybe. I mean, they're pretty old. The concept, for those who probably have never heard of it, was, my understanding was, it was kind of like you could hook it up to your cable at home. You're gonna laugh listening to this. you hook it up to your cable at home, and then it would compress the video stream and send it over the internet to your phone, so you could watch cable from your phone. Now you might be wondering,
videos on my phone.
Yeah, if only someone developed a service with mobile apps that allowed us to watch videos on our phones, right? But these were the early days, and it was a big deal. I do remember honestly people having this, and like they had it hooked up to like a DVD changer and stuff. It's the weirdest thing, but I guess it's better than nothing, right? In the olden days. The olden days of 10 years ago. Anyway, as you might imagine, there's not a lot of market for this technology anymore. So on November 9th, which is nowish, anyway, when we're recording this, the Slingbox servers will go dark, and all 15 Slingboxes in the wild will no longer be functional. There is a light at the end of the tunnel, maybe. Hacker is working on a kind of replacement software that uses VLC and some Python scripts to make it do what it do. But the hook is that apparently each Slingbox has like a password that's assigned to it from like the mothership, and the only way to get that is like to look at the traffic from when your box connects to the service. So they're like, from what I was understanding, like, unless you have connected it to the official service and we're able to capture that authentication, this open source DIY replacement won't work. And the concern is that now the service is going dark, that authentication server or whatever is not long for this world. So they're saying, like, if nothing else, make sure you grab that password that's apparently hard-coded. I mean, what the hell?
PCAP your Slingbox now.
Grab that now.
Or by the time you're listening to this 2 days ago.
Yeah. See, if you had a Slingbox, you would be able to listen to this on your phone. No, if this wasn't such like a weird old school device, there'd probably be more media coverage. I saw nothing about it until it was on Hackaday, right? Because I don't think anybody cares. But, it is another one of those examples of, you bought the hardware, right? I mean, you had an expectation it was going to keep working, and then one day they said, you know what, I'm not feeling it, and just flick a switch, and now this thing you paid for, I don't think they were cheap, I think they cost decent money back in the day, is now a paperweight. And we shouldn't have to do this like last ditch effort to make it work. I mean, at the very least, give it a password to the thing. Like, why?
Right.
In a perfect world, like the firmware would get open source and they would do all that stuff. I know that's not going to happen, especially for, I gotta imagine the Slingbox company themselves aren't in great shape, right? They got to be this is got to be the last thing they do for they close the offices if their hardware is all getting turned off. But I mean, at least let us into the thing so that these devices can have a chance at a second life and don't just end up in a dumpster. I love the idea of like a hard-coded password that's transmitted over the internet connection too,
all
like
the time. Yeah,
this is peak early 2000s engineering.
2010 security, ladies and gentlemen.
Yeah, in an emergency, there's a sticky note that has the password on the back.
For quick hacks this week, I picked 4 because we didn't get to do a quick hacks last week, and there were a couple I just couldn't leave hanging. First off, a group of Harvard scientists do nanoassembly with water. This is a really clever device. It looks like it's a resin-printed series of tubes, and it uses the fact that if you put a little floater in a puddle of water, it wants to sit in the center of it. And so then they have these angled columns that go down in such a way that it can make the floaters trade places with each other and wiggle around. If you tie nanowires to the bottom of those and raise and lower this series of chambers, it actually can braid the wires. And so here they are braiding fantastically tiny Kevlar wire by tying it to floats and just raising and lowering this container. If you've ever wondered what the heck's up with microfluidics, this is worth a look. Next up, Jay comes in with the great resistor embiggens the smallest value. This is a cool display. It looks like a giant resistor. It's got LEDs inside it. You hook a physical resistor up to the alligator clips and it displays its value for you. It's made internally of LED strip, foam, chopsticks, silver tape over glue sticks. It's an entirely low-key build, but it looks really good and must be fun to practice your resistor color codes. And of course, he got the idea for this from looking at some of the resistor color clocks we've featured before on Hackaday. Next up, the 7-segment display that's also an input device by Dave Enebuske. I was actually just talking about this in my State of the Hackaday, how impressed I was by the crazy flourishing of 7-segment displays. And one of them was this 3-element slider mechanical 7-segment display that we talked about on the podcast a few weeks ago. Here, Dave has taken it, added magnets and Hall effect sensors so that he can tell what digit is being displayed and uses that as an input. And last up, Mirage C has a long video documenting some Z-axis irregularities he's been having in his 3D prints, 3D printer tuning, and engineering approach. And this is really cool. It looks like it's down to eccentricity of the rollers that push the filament through his direct drive extruder. But half the fun here is in ruling out all the other things it could have been. Definitely take a look at this if you're into extreme tuning of 3D printers.
Well, I only have 3 quick hacks. I didn't know we were throwing the rules out the window this week. For my first quick hack, I have thin client and smartphone step-in for 3D printers, Raspberry Pi, and touchscreen. Don't have to tell you listeners that it's a little bit hard to get a Raspberry Pi right now, and if you wanted to get Octoprint running, the Raspberry Pi is pretty much the de facto platform. But it doesn't have to be the only thing it can run on. It actually can run on pretty much anything. And this article talks about how Crimson Repair uses an old thin client PC, which I think are technically called like ultra small form factor computers or something. It's very tiny, like little, like the size of a sandwich. But they're full on, x86 machines with a couple gigs of RAM. Arguably a better platform than the Raspberry Pi anyway for pushing numbers. at least when this video went out, they were pretty cheap, going for as little as $25. Will they be by the time more people start realizing this? I don't know. But I would advise you grab them up quick, because who knows when we'll be able to get Raspberry Pis again, and this offers a pretty interesting alternative. My second quick hack is from Arnav Sharma, Over-Engineered Fume Extractor version 2. As you might have assumed from the name, we actually covered this previously. And I know personally I really like to see projects develop over time. Like, a lot of the stuff we cover is kind of like a one and done. But it's cool to see like lessons learned and mistakes made and new versions come down. So we covered the first version a few months ago. And since then, the custom PCB has been evolved, and it all kind of looks, just more professional. Really, as the title indicates, it's over-engineered for a fume extractor and doesn't need to be so complicated with its, electronic speed control and all this. But hey, if you're going to do it, you might as well go big. My last quick hack comes from Hulk. And this one is IR Remote Tester helps you crack the code. Decoding IR remotes is probably about as old as Hackaday is. But it's still something that pops up once in a while, even though a lot of these remotes are now doing RF. There's still a ridiculous number of infrared remotes out there that either you want to interface with or you want to repurpose or something. So it's cool to kind of see what the state of the art of interfacing with IR is. And I like that this is kind of a twofer, because the first example is just using the IR receiver as kind of like a switching transistor to light up the LED. So you just hit the button and it blinks along with the code. And if all you want was a very simple, like, do something when I push button on the remote, like, that could be the end of it, right? You don't really need to decode it. And it's kind of cool what you can pull off with just a few passives. But if you wanted to actually decode it and act more intelligently on the signals, then that's covered too. And there's an Arduino sketch that will let you see all, like, the, what type of infrared, what the command is. And even though the technology might seem kind of obsolete by modern standards, it's cool to still see people hacking on it and keeping up with it.
And now it's time for our can't miss articles. These are fantastic original content pieces written by our lovely Hackaday writers. And this week I'm starting off with Dan Maloney's Dosimetry, Measuring Radiation. This is a neat deep dive into a scientific measurement problem, namely how you tell when people have received excess doses of radiation, say like at the workplace or whatever. And that's the experience Dan has had. Both he and I have worked in places long enough where we had to wear film badges every day. But he wanted to look at both the science behind how you do measure this and what the alternatives to the film badge are. And that's what I learned from this, is that I guess I dug into some radiation stuff a while ago for a hack. What was it? Oh, it was the detecting radiation with a comb and a statically charged piece of cigarette filter paper, where they mentioned how much radiation that was in some completely archaic units, and it had me digging it up. These days, radiation will be measured either in grays, which is how much energy per kilogram of matter, or sieverts, which actually take into account the kind of differentially dangerous kinds of radiation out there and weigh them differently. So it's a weighted average. So I guess if you get some number of alphas, it doesn't count as much as if you get some number of gammas when you're measuring in sieverts. And so there's a couple different things you can try to measure here. One is you can try to measure the amount of kind of bulk radiation the person's getting, or you can try to measure the kind of biologically weighted dangerousness of what they're receiving. And that comes in with the film sensors, which are basically, it's just a piece of film in a housing. Radiation gets in, exposes film, you see how dark it got. But they used to have filters made of, varieties of different metals to allow different types of radiation in there. So you can get a little selectivity about whether you're getting hit by highly energetic radiation or less energetic. And I thought that was pretty cool. And then he mentions the craziest radiation detector that I've ever seen, which is a quartz fiber, and it's basically statically charged, and it either attracts or doesn't to the edge of a tube that it's in, depending on how much static charge it has on it. And so as the radiation kind of knocks the static off of it slowly, you can look down the length of this tube, and it's got a little scale that says if the quartz fiber is bent this far, you've received that much radiation. And that's kind of cool. It's actually the same gimmick as the static charge up a piece of cigarette paper and hold it to a comb, but this is like the much more sensitive and kind of professional calibrated way to do the same thing.
I think maybe ever since that Chernobyl came out on HBO, like people have just enough knowledge about detecting radiation to be dangerous, but don't really get the nuance of it. And there's a lot of nuance, you know.
Right.
Even this terminology has changed over the years, and, you know, not to say that, and even the devices. So it's a really kind of cool overview of something that's very complicated, but makes it not less complicated.
Yeah, right.
But a little more approachable anyway. And I appreciate that Dan does mention like that classic civil defense Geiger counter, that like what many of us kind of like come to mind when we think of it. We're calibrating a scale that was so crazy where it was like, if the needle moves, you're probably going to die. like they literally were like, it was like 1 to 5, and I think 1 to 2 is like, maybe. And then like 3, 4, and 5, you know, it just like it's over. It's just more a matter of how long. You know, it literally was the kind of thing you're supposed to like open the hatch, put it out, put your arm out, and if it moves, go back in the thing, because it's still not time to leave. Which is to say, there's a huge spectrum of devices and sensitivities, and, you know, and then of course there's the whole thing where you're keeping track over long term versus instantaneous doses. So there's a lot to go over, and like Dan has been kind of on a run with recently, you know, I appreciate him taking these large, complex concepts and kind of breaking them down for us. I hope that I never have to worry about this in my day-to-day life, but, you know, who knows? One day I might be checking my dosimeter before I come back from hunting in the nuclear wasteland.
My favorite out of these, just from a technical perspective, is he says that MOSFETs can actually be sensitive to ionizing radiation, and that's because the layer that separates the gate from the source and drain can get, if radiation goes through the thing, it knocks electrons free, and they make it less and less sensitive. So the gate voltage, what you have to apply to it to get it to pass a certain amount of current, actually rises as it gets exposed to more and more radiation. And it's like permanent damage to the MOSFET, which I didn't know about. That must be really weird for like space vehicles. This must be a known failure mode for them. Space people must know about this, and they're probably all screaming at their podcast. But I didn't know about it, and I think it's a cool idea to use that as a dosimeter. And so you just basically measure the threshold voltage, you measure the turn-on voltages of these MOSFETs, and as they get more and more damaged by ionizing radiation, they become less good as a transistor, but, you know, you get to figure out how much dose you've been exposed to. Although he does mention that for a lot of these, the maximum amount that they can absorb before completely stopping to work is like 3 times the 100% lethal within 48 hours dose. So it's one of those, you know, if your MOSFETs stop working, you're probably already in really bad shape. But it does make me think, I wonder how measurable this is. I wonder how finely I could measure a MOSFET's like turn-on voltage, and then, you know, get a little americium or something, put it next to it and see if I can make it move. That might be a sweet and simple, fun project, and I'd love to see someone taking this concept and pushing it further, because now we've got ADCs. Like if you think about those analog to digital converters that they have for doing cardiography, for measuring hearts, they're like 24-bit ADCs, so they can measure tiny differences in voltage changes. I wonder if you could do this with a, you know, like one of those ultra precise ADCs and a MOSFET.
Well, it has diodes too. He was talking about in the kind of previous to that, you use the diodes, and I wonder if those. I don't know if you've ever seen. They have these little cheap, you know, quote unquote Geiger counters that you can put into the headphone port of your phone.
Okay.
And there's like an app that goes along with it, and supposedly there's something in this thing, but they're so tiny, it's like just like an inch long little tube. And I wonder if there's just like a diode or something in there, and they're somehow counting what's getting through it.
I know we've seen this done before, and I'm going to throw a link in the show notes on someone who was using a pin diode. I think it's like a BPW34, actually. I'm just looking at it now, as a Geiger counter. And this is a really neat project. My father actually read this one on Hackaday and tried to recreate it, and says that it's really sensitive to kind of the analog signal conditioning, and he had trouble with it. But looks like a promising one if you want to make a pin diode Geiger counter.
Well, this week we are getting a double shot of Dan Maloney, because I also picked a Dan Maloney article. Al got 2 in 1 week, so it's Dan's turn. This one is The WOW Signal Revisited, Citizen Science Informs SETI Effort. And there might be some groans. I know not everybody's into this kind of thing, but I'm a big space nerd, and this sort of thing fascinates me. For those, the recap for those who aren't aware, the WOW signal was picked up in 1977 by a radio telescope in Ohio. And it was so powerful compared to like the noise floor that the person watching the printout circled it and put "wow" in the margin. So it's not particularly a creative name, but it's stuck since 1977. It also makes for a very awkward reading when it's "wow!" exclamation point every other line in the article. But that's not Dan's fault. He's just working with the hand he's given. But since then there's been a lot of efforts to try to figure out what this was. There's theories that it was something local. It was a screw up in the machine. It was something satellite that passed by. There's all kinds of stuff. This is like the only data point that there is. Like this one printout that is literally like marked with ink. So there's been a lot of efforts over the years, and most recently, in May, there was an attempt to do a coordinated observation of one of the stars that was roughly in the area that the telescope was pointed at in 1977 to see if they can find another WOW signal. And, spoiler alert, they didn't find anything. Mm-hmm. But this is important. It's important to do these kind of multi-telescope things, because having 2 different viewpoints can help isolate a lot of these possible causes. So obviously if it's a local thing, it's not going to be happening at both of them. If it's a satellite that's passing by, it wouldn't pass over both of them at the same time, that kind of thing. But by using 2 different telescopes that point at the same source at the same time, you can, if you did get a signal, you'd be able to check it. And you could look at this as a failure, I suppose, because they didn't pick anything up. But you have to start crossing things off the list, right? You have to see where the signals aren't coming from before you find where they are, I suppose. It's notable because it was that first kind of multi-telescope observation, and they're taking this more serious than I guess they did in the 70s. And SETI, of course, is search for extraterrestrial intelligent life, and that it does what it says on the tin, right? They'll find a lot more interesting astronomical stuff before they find ETs, right? So it's still worth studying these things, and if we find a signal and can't identify it, the least likely thing it's going to be is an alien. But we still have to investigate it, and we still have to figure out what it is. And new discoveries will certainly be made along the way. So it's still worth doing, even if it isn't the WOW that people have been hoping for. But one thing I did think was interesting is that all these observations are done in the hydrogen line. And somebody said, well, why is that? If who made that like the frequency we're looking for, right? And that kind of, if you look into that, it kind of takes you down a rabbit hole where, like they say, the hydrogen line frequency of 1420 megahertz is relatively quiet in the radio spectrum, but there's a lot of it out there, So what you pick up tends to be important. So they use that to kind of map the skies. And the idea was that if we figured out it was good for mapping space, then other life form might have figured that out. And then the theory goes that they would say, hey, well, if this is the frequency they're mapping the star systems, maybe we should holler at them on this frequency. It's kind of a shot in the dark, but so is, searching for aliens, I guess.
Yeah, the whole thing is, right? Like, it's all just beaconing out there and hoping something is going to hear it. Like, it's not even going to be somebody. It's really interesting, and I think Dan did summarize the WOW signal very well by saying that this was, it's a one-off. It doesn't prove anything. That makes it, kind of the worst possible thing. It's observational, so you can't just do the experiment again. And it's a one-off observation. So what are you going to do? And the answer is go back and look again. And that's exactly what they're doing here. And they did not find more aliens over there. But the angle that I think is really neat about this is that this kind of was spearheaded / agitated for by Alberto Caballero, who is actually an amateur scientist. And he's looking for habitable exoplanets in general and is kind of getting a collection of the best places to look for something like this that might end up actually finding a signal someday. Because, you know, if you're going to look around, you don't want to look totally randomly. You're wasting a lot of telescope time. So you at least want to kind of point the scope at a habitable planet, and that's the game here. But I think that project in and of itself is a really cool citizen science project where they're just looking for planets that kind of go in front of stars, and they look at this occultation period and the dimming from there to figure out how far outside the stars the planets are, so they can use that to figure out, you know, whether it's in the nice warm zone or whether it's too far away for any of that. So it's really cool citizen science being done to make this survey possible. And I think that alone is kind of cool. You know, I wasn't expecting anything out of the WoW signal anyway. So, like, it's totally good that they did this and we're like, yeah, well, we did it again and we didn't see anything. It doesn't, of course, none of this proves anything. And this is the part of science that drives everybody crazy, is that, you know, a negative result is not proof that there's nothing out there. You know, I want to believe, right? But I actually don't particularly want to believe. I'm cool with it either way. This definitely makes it look less likely that that particular star / planet is habited, because they're sure as heck not broadcasting now.
I guess the record keeping or whatever back then was not super detailed. So there's a lot of questions about what it actually was the telescope was pointed at in 77.
Yeah.
So it says that, you know, they tried to narrow it down based on, like you were saying, you know, how big they are, how far they are from their suns. But I mean, there's like at least 8 possibles in that window, you know, and this was one of them.
Yeah.
So 7 more to go. But if you relax some of those criteria, because, you know, it's funny, we assume life can only exist on a planet like Earth, which of course is a very narrow-minded approach. But if you relax that and say, okay, well, they don't have to be Earth-like, then that jumps it up to like 600 stars in that area, each with its own planets, and that's like, well, we'll be here all day. And this is just a tiny little speck in the sky. So you can see how ridiculous it is to try to scan all of space for the aliens' hello signal, which might not be there in the first place.
Yeah. But you do have to just, if you're going to look for them, you do have to just kind of take your best guess and go for it. And that's, you know, at least that's what they're doing here. So I'm down with that.
And I think it's somebody in the comments pointed out that, you know, we transmitted the Arecibo message like as a one-time thing. You know, I wrote about that earlier. You know, we came up with this message, hey, I'm Earth, this is what we look like. And we shot it out with all the energy we could muster one time. You know what I mean? And that was it. You know, so like, what if you were on the other side of the galaxy and you picked up that one thing and you're like, oh, wow, what was that? And then you go look for it. Well, it's not coming again because we shot it off one time, you know. And
that's kind of stupid, isn't it?
And our background emissions are going to be way lower than that one signal. So, like, is it possible that the WoW signal was some other civilization's, you know, one scream into the darkness? Who knows, you know? We could be pointed right at them, and they would never make a signal like that because that was their big attempt. And then their 8-legged, 4-eyed scientists talked them down from doing it again. So
exactly,
you know, we'll never hear another WoW signal from it. But it's all who knows? It's all anybody's guess is as good as another.
And that's the end of the Hackaday podcast for this week. Thank you for listening. If you have anything to say to us, let us know, editor@hackaday.com, or head on over to hackaday.com/podcast, where you'll get both the links and some comments. And if you see anything cool or do anything cool, send us a tip, tips@hackaday.com. And until next week,
keep on hacking.
If you see anything cool or anything, what?
You see anything or do anything, isn't it?
If anything goes anywhere, just write us, okay? Well, my first jet lag.
Tell you what, this sun's pretty promising. We should use it for energy or something. Is anybody looking into this? And my last quick call. Quick call. Okay, that's good.
Yeah.